The topic covered in today's tutorial is basic trigonometry, so let's get started. Okay, so here we have a right angle triangle. So let's input the angle theta. Now from theta we need to label the three sides. So the side that is opposite is called the opposite, and we have the adjacent, which is the one that's next to the angle theta, and then the hypotenuse, which is the long one. Now the three trigonometrical functions that are going to be dealt with during this presentation are the sine, cosine and tangent. Okay, so I've made a small diagram in the top right hand corner of our triangle, our right angle triangle. So we have theta, we have A for adjacent, O for opposite and H for hypotenuse. Now for the sine function, sine theta equals opposite over hypotenuse. For the cosine function, cos theta equals adjacent over hypotenuse. And for the tan function, tan theta equals opposite over adjacent. So make a note of these and then we'll carry on with the presentation. Okay, now one useful observation is the following relationship between the three functions. So we have sine theta divided by cos theta equals opposite over hypotenuse divided by adjacent over hypotenuse, which equals opposite over adjacent, which is equal to tan theta. Okay, so make a note of this because it will come in handy throughout your studies. Okay, so we're going to have a look at using the sine function. So we're given the drawing, so theta equals 22.5 degrees, the hypotenuse equals 10 centimeters, and we're asked to find x, which is the opposite side. So we know that sine theta equals opposite over hypotenuse. So this is going to equal the opposite, which is x, over the hypotenuse, which is 10. Now we're given theta as 22.5 degrees. So the sine of 22.5 degrees equals x over 10. Now we have a fraction here, so if we multiply both sides by 10 it will eliminate this 10 from underneath. So we can say that 10 times the sine of 22.5 degrees equals x. Now multiplying that out, this gives x equals 3.83 centimeters. So let's have a look at another example. Okay, so in this next example we're given theta equals 35 degrees, the opposite side is equal to 6.5 centimeters in length, and we're asked to find the hypotenuse, which is x. So I'll give you a few minutes to work through this example and then I'll come back and work through it with you. Okay, so here we have sine 35 degrees equals opposite over hypotenuse. So the sine of 35 degrees is equal to the opposite, which is 6.5, over the hypotenuse. So if we multiply through by x, which is the hypotenuse, we have x times the sine of 35 degrees equals 6.5. Therefore, we have x equals 6.5 divided by the sine of 35 degrees, which is 0.574, which equals 11.3. So x is 11.3 centimeters long. Okay, so let's have a look at another example. Okay, so this time we're using the cosine function. So we're given theta equals 30 degrees, the hypotenuse is 15 centimeters, the adjacent side is y centimeters, so we're asked to find the adjacent side. So we know that cos theta equals adjacent over hypotenuse. So the cos of 30 degrees equals y divided by 15. Therefore, multiply through by 15 to get rid of this fraction. We end up with 15 times the cos of 30 degrees equals y. So therefore, the cos of 30 degrees equals 0.866. So 15 times 0.866 equals 13 centimeters. So y equals 13 centimeters in length. Okay, so let's have a look at another example. Okay, so for this we know that cos theta equals adjacent over hypotenuse. So the cos of 40 degrees equals adjacent, which is 25, divided by q, which is the hypotenuse. So now to get rid of the fraction here, we multiply through by q. So we end up with q times the cos of 40 degrees equals 25. And we'll calculate the cos of 40 degrees. So q times 0.766 equals 25. Therefore, q equals 25 divided by 0.766, which equals 32.6 centimeters. So q has a length of 32.6 centimeters. Okay, let's have a look at another example. Okay, this time we're looking at using the tangent function. So we're given theta equals 60 degrees. We're given the adjacent side as 5 centimeters long. This time the opposite side, x, is what we're after finding. So we know that the tan of theta equals opposite over adjacent. Therefore, the tan of theta equals opposite, which is x, over adjacent, which is 5. Now to get rid of the 5, we need to multiply through by 5, and that will get rid of this fraction. So we can also say 5 times the tan of theta, which is 60, equals x. Therefore 5 times the tan of 60 degrees is 1.732 equals x, so x equals 8.7 centimeters. So the opposite side to theta, x, is 8.7 centimeters long. Okay, let's have a look at another example. Okay, so in this example we are given theta at 40 degrees. The adjacent side is x centimeters. The opposite side is 17 centimeters. So we're asked to find how long the adjacent side is. So I'll give you a couple of minutes to work through this example, and then I'll come back and I'll work through it with you. Okay, so again, the tan of theta equals opposite over adjacent. So the tan of 40 degrees is equal to opposite, which is 17, divided by the adjacent, which is x. So I can replace that a with x. Now you can see we've got a fraction here, so again we need to multiply through by x. So x times the tan of 40 equals 17. So therefore the tan of 40 is x times the tan of 40, which is 0.839 equals 17. Therefore we have x equals 17 divided by 0.839, which equals 20.3 centimeters. So the value of x is 20.3 centimeters, and the adjacent side is 20.3 centimeters long. Okay, so let's have a look at this example. Here we're given a triangle where theta is not given, but we're given the hypotenuse and we're given the opposite side. So we're going to use the sine function to find theta. So we say sine theta equals the opposite over the hypotenuse. So sine theta equals opposite, which is 5, divided by the hypotenuse, which is 10, which is 0.5. 5 divided by 10 is a half. So now we have sine theta equals a half. So we can move sine over to the other side and say theta equals arc sine, or sine to the minus 1 times 0.5. Therefore, if you use a calculator to calculate this, you'll find that theta equals 30 degrees. And when you're calculating this, don't forget to make sure that your calculator is set to degrees and not radians. Okay, so let's have a look at another example. Okay, so in this example again, we're not given theta, but we're given the hypotenuse, which equals 10, and we're given the adjacent, which equals 5. This time I'm going to use the cosine function. So cos theta equals adjacent over hypotenuse. So the cos of theta equals adjacent, which is 5, divided by the hypotenuse again, which is 10. So this equals 0.5. Again, arc cos over the other side, so theta equals arc cos, or cos to the minus 1 times 0.5, and using your calculator set to degrees, you'll find that theta equals 60 degrees. Okay, let's have a look at another example. Okay, in this example, again, we wanted to find the angle theta. We're given the adjacent side's value of 10 centimeters in length, and we're also given the opposite side value of 5 centimeters in length. This time we want to use the tan function. So tan theta equals opposite over adjacent. So the tan of theta equals opposite, which is 5, over adjacent, which is 10, again, which equals 0.5. So therefore arctan, or when we move it over the other side, theta equals arctan, or tan to the minus 1, times 0.5, and if you use your calculator set to degrees, theta will be equal to approximately 27 degrees. So okay, that's my final example. If you've got any particular examples that you'd like me to work through, please put them in the comments, and don't forget to subscribe to my channel.